Hello everyone. Today we're going to do a packet switcher of Cisco 3 version 7.11.5.1 packet switcher compare layer 2 and layer 3 devices. Part 1, compare layer 2 and layer 3 switches. Part 2, compare a layer 3 switch and a router. In this activity, you will use various commands to examine 3 different switching topologies. Okay, different switching topologies. Here's a physical topology. Let's go to logical. You will see the 3 different switching topology. This is a switching topology. This is 1, 2, 3. These are the 3 different switching topology. We're going to work on these topologies and compare the similarities and the differences between the 2960 and the 3650 switches. These numbers are the model number, the model 2960 switch, model 3650 switch. 2960 switch is a traditional layer 2 switch. 3650 switch is layer 3 or multi-layer switch. You will also compare the routing table of a 4321 router with that of a 3650 switch. This number is the router model number. All right. Instruction step 1, compare layer 2 and layer 3 switches. Examine the physical aspects of D1 and ASW-1. This is a layer 3 switch. This is layer 2 switch. Layer 3 switch, layer 2 switch. Or the 2960 switch, and this is a 3650 switch. All right. So examine each individual switch has how many physical switch ports. Let's go to D1 first. Here's a physical. Here's a physical. Let's back off D1. How many switch? Let's zoom in to see. These are the 24 switch ports. It's a fixed gigabit Ethernet switch port, and there are four switch ports. They are modular switch ports, the modular gigabit Ethernet switch ports, the SFP module. SFP stands for small form factor pluggable. So there are totally 24 plus 4 is 28 switch ports. D1 has 28 switch ports. And let's look at this 2960, the layer 2 switch, physical. Yeah, the switch port is here. These are 24 fast Ethernet switch ports, 24. And these 2 switch ports are gigabit Ethernet switch ports. So 24 plus 2, total 26. So layer 2 2960 switch has total 26 switch port. Okay, here I give you the answer. All right, so here 26 switch is 24 plus 2, 26 physical switch. 3650 D1 switch has 28. All right, next, how many faster Ethernet and gigabit Ethernet switch ports does each switch have? Here we use, let's go to D1 first, still enable. We use a show IP interface brief. Okay, so how many fast Ethernet and gigabit Ethernet? D1, these 24, there are 24. This is a fixed gigabit Ethernet switch port. This 24 is for this part, this 24 physical fixed gigabit Ethernet switch ports. That is 24. And there are 4 gigabit Ethernet. This 4 is modular. This modular is modular. SFP modular switch port. Okay, gigabit Ethernet switch port. So all these 28 switch ports are gigabit Ethernet switch ports. And D1 doesn't have fast Ethernet. Doesn't have fast Ethernet switch ports. Okay. And look at the axis. Enable show IP interface brief. Yeah. This layer 2 switch, the 24 switch ports are the fast Ethernet. From the physical, we can see these 24. These 24 switch ports are the fast Ethernet switch port interface, or yeah, these 24. And then there are 2 gigabit Ethernet. This 2 gigabit is these two gigabit Ethernet. So now we know the layer 2 switch has 24 fast Ethernet and 2 gigabit Ethernet. So now I give you the answer here. All right, so 2960 is layer 2, 3650 is layer 3 switch. This is the answer. 24 fast Ethernet, 2 gigabit. Layer 3 is no fast Ethernet. All right. The 28 gigabit ports. And the next one, the list of the transmission speed of the fast Ethernet and the gigabit Ethernet switch ports on each switch. What is the transmission speed? We need to find the transmission speed of the switch port, faster Ethernet switch ports and the gigabit Ethernet switch port. Because D1 layer 3 switch doesn't have the faster Ethernet switch port, so we go to as the layer 2. Okay, and here we need to go inside of the switch port to find out the speed. We just pick up the first interface. So show interface F01. All right, so there are a lot of information about this interface, but which one is for speed? Look at here. And the BW. Okay, BW. This is one, BW is bandwidth. Bandwidth is about the speed, transmission speed. So here, I give you the, explain you from here. All right, so here the fast Ethernet is 1 followed by 50. Okay, 1 followed by 50 kilobits. There's a 10,000 kilobits equals, because K is 1,000. 1,000 is has 3 zeros. So we add 3 zeros after the 5 zeros. So we turn this number into bit, the kilobit into bit. Okay, so we add 3 more, so totally has 8 zeros. So now it's a 100 million bits, 100 million bits. The million is mega. So 100 million bits equals 100 megabits per second. This is the speed of the fast Ethernet here. So we find this answer about a gigabit. Gigabit is on the D1. Let's go to D1. Show IP, show interface. We pick up the first one as well, G101. Okay, so we get inside. Let's look for the bandwidth, BW. Here is the 1 followed by 6 zeros, kilobit. Okay, let me get here. All right, so you will see the answer. So here is 1 followed by 6 zeros, kilobit. So 1,000 100,000 kilobits. The turn into the bits is, the K is 1,000. 1,000 has 3 zeros. So add 3 more zeros. So it's 1 followed 9 zeros. So it's 1,000 million bit. 1,000 million bit is 1,000 megabit. All right, because million is mega. So 1,000 megabits equals 1 gigabit per second. So 1 gigabit per second. That is the speed of gigabit Ethernet switch ports. Okay, or the 1,000 megabit. Sorry. So we find this answer. The next, are either of the two switches modular in design? Yes. The D1 is modular. Here there's a module. Okay. There's a module. SFP module. But this one doesn't have module. This is layer 2. No. All right, so the answer is here. Show you. All right, yes. 3650 switch, layer 3 switch is modular. B, the switch port of 3650 switch can be configured as layer 3 interfaces by entering the no switch port command in interface configuration mode. This allows technicians to assign an IP address and a subnet mask to the switch ports in the same way that they are configured on the router interface. The question is, what is the difference between a layer 2 and layer 2 switch and a layer 3 switch? What is the difference between layer 2 and layer 3 switch? Here we answer another question, that is, what is layer 2 and what is layer 3? Layer 2 is physical, layer 3 is logical. Layer 2 address is a physical address. We call that MAC address, MAC, MAC address. Layer 3 address is a logical address. We call that IP address. So now we know the difference between these two switches. All right. So here's the answer. So layer 2 switch makes forwarding decisions only based on layer 2 physical MAC address. And the layer 3 switch makes forwarding decisions based on both layer 2 MAC address and the layer 3 IP address. That is because layer 3 switch can be configured on interface with IP address and also can be configured with the routing protocols like a router. That is the answer. All right, the next, what is the difference between the switch's physical interface and the VLAN interface? Okay, here's the answer. Physical interface, the functionality of the physical interface is to physically connect end devices to the network. It's a physical interface you can see, physically see at the touch interface. And also you can plug the cable into the interface to connect the device to the network. So that is the physical interface. The VLAN interface is, we call that is SVI. SVI switch virtual interface. It's virtual interface. It's invisible. The functionality of VLAN interface is for the remote management purpose. Because VLAN interface is used to configure the switch with an IP address on it, so the switch can be managed remotely. So it is for the remote management purpose, VLAN interface. Okay, this is the difference between the physical interface and VLAN interface. Next, at which layer do 2960 and 3650 switches operate? 2960 is a layer 2 switch, so it operates on layer 2. 3650 switch is layer 3 switch, so it operates on layer 2 and layer 3, both. So here is the answer. Okay, so layer 3 operates on both layers. Okay, next, issue the show run command to examine the configuration of D1 and ASW-1 switches. So layer 3 and layer 2 switches, do you notice any difference between them? Okay, let's do here. All right. Layer 2 and layer 3, what's the difference between them? Here's the ports. First is the ports. This is a 2960 switch. They have 24 fast Ethernet switch ports and 2 gigabit Ethernet switch ports. This is D1, layer 3, the 24 fixed the fixed gigabit Ethernet. This is 4 modular gigabit Ethernet. So all interfaces are gigabit Ethernet switch port. Here is a 24 fast Ethernet and 2 gigabit Ethernet. All right, this is the first difference. The second is interface format. Let's look at here, the format. This 2960. Here, look at the format of the interface. Here is 0, 1. The first number, the 2 numbers. Okay, first number is module. The second number is port. So it's the 2 numbers. But here on D1, the format is 3 numbers. All right, so first number is stack. The one is stack. The middle number, 0, is module. The third one is port. So the format is different. It's a second difference. The third one is, we don't need to show run, right? Yes, okay. Can show run. All right, so enable show run. The third difference is about the IP address. On D1, on the physical interface, G0, G111 and G112, this physical interface is configured with IP address. These two interfaces are the modular, is on the modular switch port. Okay, here is IP address and subnet mask configured on this 2 physical interfaces. But on the 2960 switch, the layer 2 switch, no IP address configured on any physical interface. But here is a VLAN, it's different. All right, so no IP address configured on physical interface on 2960 switch, but D1 has. Another one, this is a third difference. The fourth one is here, look at here. There's a no switch port configured on D1, but on the layer 2 switch, no this command, no switch port. All right. This is the fourth one. The fifth one, and to look at here. Here, there's IP routing on D1. IP routing is enable IP routing. So D1 can configure the routing protocol like an OSPF on D1, like a router. But on layer 2 switch, there's no IP routing here. Yeah, no IP routing. So that is totally 5 differences. This is a difference. Okay. And also, they ask us to the similarity. Oh, no, they don't see the similarity, right? No. Okay, only difference. Okay. So here is the answer. The ports, interfaces, interface format and address, IP address, no switch port, and in IP routing. Okay. So next, try to display the routing table on D1 and ASW-1 using the show IP routes command. Why do you think the command does not work on ASW-1 but works on D1? Works on D1. Okay, let's go to show IP routes to see the routing table. Show IP route. IP route. Yeah, here is the routing table show up. Let's go to layer 2, 2960. Show IP route. So here's invalid input detected at this marker, So that means the layer 2 switch doesn't support this command. Or we can show like this, show IP space question mark. So from the option list, we cannot find the show IP route. No, but here on D1, we do the same thing, show IP space question mark. Yeah, we can see the route here. So D1 supports this command, show IP routes, but ASW-1 switch doesn't accept, doesn't support. Okay. Why D1 works, but ASW-1 switch doesn't work? That is because this switch is 2960 switch, is a layer 2 switch. Layer 2 switch only function on layer 2, make forwarding decision based on layer 2 physical MAC address. While D1 is a layer 3 switch, it functions on both layer 2 and layer 3. And layer 3 allowed to route packets and make forwarding decision based on the layer 3 IP address information that layer 2 switch cannot do. That is why the command show IP route works on D1 switch, not ASW-1 switch. Okay, now we answered this question. I show this answer here. Okay, here's the answer. Okay, next step to compare layer 3 switch and router. In the past, the switches and routers have been separate and distinct devices. The term switch was set aside for hardware devices that function at layer 2 router. Router, on the other hand, are devices that make forwarding decisions based on layer 3 information. They use routing protocols to share routing information and to communicate with other routers. Layer 3 switches, such as the 3650, can be configured to forward layer 3 packets. Entering the IP routing command in global configuration mode allows layer 3 switch to be configured with routing protocols, which gives them some of the capabilities of a router. Although similar in some ways, layer 3 switches are different from routers in many other aspects. Open the physical tab on D1 and R1. So now we are going to compare D1 and R1. All right. Okay, let's go to physical part. R1, D1. Okay. So what's the question? Do you notice any similarities between the two? Do you notice any differences between two? So similarity and difference. All right, physical. Let's go to physical. All right. The physical one here, the R1. The similarity is both have the console port. Here's the console port. D1. Okay, I like to hear this side. This R1, this is D1. Okay. Yeah, this is console. Console ports. Here's the console ports are here. Console ports are here. And USB ports. USB ports both have USB ports. Here's the USB ports. Here's the USB ports here. USB ports here. And the Gigabit, these are Gigabit Ethernet ports. Both have, this is a Gigabit Ethernet ports on R1. And both have module. Both have, D1 has a module, SFP module. And on R1, you can add different modules here, right? That's a similarity. Both have a console port, a USB port, and Gigabit Ethernet ports and module. The difference is D1 only have Gigabit Ethernet interface, because this is a fixed Gigabit Ethernet. This is modular Gigabit Ethernet. So only have Gigabit Ethernet, but R1 has different type of interface. They have a Gigabit Ethernet, and you can add, you can add a serial interface here, and you can add the T1 interface or Gigabit Ethernet interface or different type. And another difference is this modular Gigabit Ethernet accepts the copper and fiber connection, depending on what type of SFP module inserted. But R1 accepted different various connection type, like a serial connection and asynchronous. Another difference is D1 has more gigabit Ethernet ports. Like here is 24 plus 4 is 28, but here on R1, the gigabit is much less. Gigabit Ethernet ports is much less. All right, so this is a difference and the similarity between layer 3 switch and the router. Okay, I give you the answer here. The next is issue show wrong command and examine the configuration of R1, D1. What difference do you see between two? R1, D1, show wrong. Okay, show wrong. Show wrong. D1, R1. Okay, enable show wrong. And this one, D1. No, D1 right here. All right. Let's compare the show wrong, the configuration. The both interface, the IP address compared here. Okay, the 192.168.10.1 here is 11.1. Here are the same 10.1, 192.168.10.1, and 11.1. And the subnet mask are the same. So they have the same IP address configured, but on different interface. On D1 is on interface G111, G112, these two interfaces. But on R1 is 000, 001. So interfaces are different. That's a difference. Okay, I give you the answer here. Show you the answer. Next, which command allows configuration of D1 with an IP address on one of its physical interface? Which one is a no switch port? Yeah, switch port command. Right. Because you're looking at D1. Is D1. Yes, D1. This one, no switch port. No switch port here is a no. This is the switch port on layer 3 switch. So first, the no switch port is no layer 2 switch port. We need to turn off the layer 2 switch port function. Then on the same switch port, we turn on the IP address, layer 3. All right, so before we configure the IP address, layer 3 information on this switch port or interface, we need to turn off the layer 2 switch port functionality. All right, so this is the answer. Okay, next, use show IP route command on both devices. Do you see any similarity or differences between the two tables? Okay, so D1, show IP route. All right. And R1, show IP route. All right. What's the difference? The difference, similarity is both these two devices have the code You know, this is the routing table. Routing table, the code, they have the code. Code are the same. All these codes. The S is static, S is static, C is connected, C is connected. So the codes are the same. And also they have the same network address here. The C is connected, direct connected. This is the network address. 192.168.10.0/24. Here, the same network address. All right, here 192.11.0/2 /24. Okay, here's 11.0/24. All right, the same. What the difference is, D1 doesn't have L code. Here, R1 has a code L, is a local. The local is the local IP address on the interface. IP address. Yeah, from here you can see the /32. If it's when you see /32, you will know this address is IP address, and C is the network address. But on D1 doesn't have L, code. All right, so that's the difference. All right, so I give you this answer. So it's here. Okay, here's the codes are the same, network is same, no code, no L code. So now analyze the routing table of R2 and D2. What is present now that was not present in the configuration of R1 and D1. So now we're going to compare the R1 and R2 and D2. Just now we compared D1 and R1. Now we compare the D2 and R2, these two devices. So we'll go to routing table. So we need to, this R2 routing table is show IP route. Okay, enable show IP route. All right, and D2. Let's do the enable show IP route. Route. All right, so what the question is, what is present now that was not present in the D1 and R1? Okay, D1 R1, D1 and R1. Yeah, CC. Okay, here's the CC, D1. R1 is CL. All right, so D2 and R2, the routing table is CCC, CL. So the O appear here. O network. O is from this code. Is always OSPF. So now is OSPF appear here. These two O network. So here's the answer. All right. So R2 and D2 both have OSPF configured. Yeah, we can see O configured. The difference, the both are learning network from each other because they are connected to each other, right? Yeah, here they learn information from each other. All right. So the question is, the next one, which network in the routing table of D2 What's the question? That was learned from R2. D2 are from R2, this one. 1.1.1.0, this network. The D2 learn this network from R2. Okay, let's see the R2. Is this network 1.1.1.0, this one, this network. So D2 learned this network from R2. Okay. Okay. All right. So next, verify that each topology has full connectivity by completing the following tests. So from pin to test the full connectivity, pin from 1 to 2 and 3 to 4, and from 5 to 6 and 7. Let's go to pin from 1. So pin 2, PC2, okay, here, PC2, IP address is 192.11.10, okay, 11.10, 11.10. All right, so they should be successful. Yes, it's successful. All right, so from PC3 to 4, it's pin. PC4 is here. It's 11.10 here, 11.10. So 192, 168, 11.10. Isn't it? 11.10, yes. Okay, success. It works. So next is from PC5 to 6 and 7. Pin. Let's see, PC6 is 10.10. Pin 192, 168, 10.10. All right, takes a little bit longer. Okay, yeah, success. At pin PC7 is 11.10. Okay, pin 11.10. Okay, success. So all these pins are success. So in all these 3 examples, each is different network. Okay, which device is used to provide the communication between networks? In this, on this topology, D1 provide communication. This topology is R1 provide communication. In this topology is R1 and R2 and D2 provide communication. All right. So is D1 R1, D2 D2 R2. Okay, so next is why were we able to pin across networks without there being a router? In a router. Okay, this D1 and D2, they are not router, but still can ping. That is because the multi-layer, because this D1 and the D2 are layer 3 switch. Okay, so multi-layer switch or layer 3 switch can route between networks as long as it is configured with an IP address that has IP routing enabled. IP routing must also be enabled if you plan to run routing protocols like OSPF on the switch. And the no switch port command must be enabled on the interface in order to assign an IP address at a subnet mask on the switch's physical interface. That is the answer. Okay, Let me show you the answer. Okay, here's the answer. So next, bonus questions. We see that routers are layer 3 devices and the conventional non-layer 3 switches are layer 2 switches. However, we can assign an IP address to a management SVI interface of a layer 2 switch. How is this possible if the switches are layer 2 devices? All right, how possible? How is it possible? The possibility comes from an embedded server, which is located inside the layer 2 switch. That server can be reached over layer 3, and the server enables Telnet, SSH, or HTTP access to the switch from across the network, so that the switch can be remotely managed and configured. However, this SVI interface is just for remote management purpose, not for the data forwarding function. Okay, here's the answer. All right, so we finished. This packet tracer. Compare layer 2 and layer 3 devices. Okay, thank you for watching my video. If you like my video, please thumbs up and subscribe my channel and share with your friends. See you next time.